Good afternoon, good evening, good night, good morning, depending on where you are in the world. This is Dr. Ferdinand from Gold Standard GAMSAT. We're about to do a significant study session. No matter if you're at the beginning of your uh, preparation or towards the end with a lot of experience, we will get to your level. Okay. So you will learn something over the next hour. So the plan is that we're going to be completing 5 practice questions from ACER's GAMSAT Practice Questions. That's the title of this ebook. You have free access to this if you've registered for the exam. You just log into your um, account with ACER, and they provide this booklet, GAMSAT Practice Questions, for free with your registration. We're going to be completing the first unit. The first unit in section 3 is based on the cardiovascular system. Most of the questions can be answered with a very limited understanding or almost no understanding of the cardiovascular system, but a couple of the questions requires a basic understanding of the cardiovascular system. And it is a particularly important topic because it is one of the most common topics in biology, is the cardiovascular system throughout the years. You're going to find it throughout ACER's practice materials, and you're also going to see that it's a common topic on the exam for biology. Again, some of the questions you'll be able to answer without previous knowledge, but some of the questions definitely it's helpful to have previous knowledge. So what we're going to do is just get a general idea of this section. Then I will go into the anatomy of the cardiovascular system. So we'll just do a little backgrounder. So for those of you in biomed, it's going to be super simple, but some of you are still just learning. So we're going to talk about the cardiovascular system, take a look at what happens when you add in a placenta to circulation. And then I will give you the time to complete the first unit. I know that some students might have already completed the 5 questions, but if not, I will give you the time to complete the 5 questions. Then we will go through the work solutions. And then the bonus time, I'm going to give you 3 practice questions, which are, I think that most students who've sat the exam recently would say they're more updated in terms of the style and the level of difficulty. So we're going to first get the point of view from ACER so that you have a clear sense of the exam, even though some students will say that the ACER's GAMSAT practice questions is a little bit well, I wouldn't say a little bit, but it's easier than the real exam. It doesn't matter, even though it's easier. There's a few of the questions that still would be of the standard of the exam, but a couple of the questions, yeah, are much are easier than the actual exam. But this is warm up, right? You're getting warmed up, and then I'll also add those extra questions to make sure that you are at the correct level. Okay, and of course, this is being recorded so that you can watch it later if you wish to do so. So I'm going to just remind you of something. Okay, one of the things, the reason we're doing the circulatory system is that as some of you may know, the book is color coded so that the high important topics, the low level important topics, low level in blue, high level in yellow, and medium level in green. And the cardiovascular system is way down there, as you can see, and it's in yellow, which means it's a high level importance chapter for this exam. And some of you have seen this already, perhaps more than once. So I'll just say, take a screenshot if you've never seen this before, and just so that you have a clear perspective on the importance of mathematics to biology, to all Section 3, but in particular, because we're talking about biology today. So although we're going to do some background content to make sure that you have the assumed knowledge necessary for this section, please keep in mind that it's still going to be mostly graphs, tables, and diagrams. And so we will definitely be doing that as well today. Okay, so let's jump into the cardiovascular system, and we'll do a quick rundown. Okay, so this is in chapter 7, and just for a little bit of perspective, on the first page of the chapters, it tells you what's important to memorize, understand, or what is the relative importance of the chapter. Now, just so that you know, there's 16 chapters in this book, and this book has a relative importance level of almost 20%. So 1/5 of the importance of assumed knowledge out of 16 chapters is the cardiovascular system, just so that you get a relative idea as to the importance. And so this is what we're going to start with, just to give the basic concept. Okay, so we have a cardiovascular system set of tubes that'll work partly in series, which means one thing after another, and partly in parallel, where it sort of breaks up into parallel components, symbolized here to be the capillary bed. Of course, just as a general sense of the cardiovascular system, anytime there's a blood vessel that is moving, of course, this is the symbolically presented as the heart. Anytime there's a blood vessel that's moving away from the heart, it moves away from the heart in arteries. So it doesn't matter if it's like this, which is symbolized as blue blood, meaning deoxygenated, or symbolized as red, meaning oxygenated. It doesn't matter if it's deoxygenated blood. If it's moving away from the heart, it's an artery. And here there's oxygenated blood, symbolized as being in red, moving away from the heart. And so that this is an artery, and this is the largest artery, of course, in your body, which is the aorta. And of course, these are just ways of symbolizing the color of the blood. Your blood is never blue. It goes from red to a sort of a darker color, but not actually blue. So what you see when you look at your arm, it's more of a optic illusion. Okay, so the circulatory system can be divided into two components. You can see here the systemic circulation, which means the body system to all the body tissues, the tissues in your body, your left kneecap, your kidney, your liver, so on. So blood is in circulation in your body system, but blood is also in circulation to and from your lungs. And so that's called the pulmonary circulation. And this is a very important way to divvy up the way blood circulates. Of course, because it's circulation, it's going in a circle. So you can start anywhere in the circle. Let's talk about the oxygenated blood leaving your heart. So the oxygenated blood leaves your heart in arteries and goes to your body systems. And so basically, the level at which cellular respiration is occurring is obviously in the cells. And we need oxygen, and that helps us to produce energy. And the currency, short-term energy storage molecule, is ATP. And we use oxygen to produce that in highest quantities through aerobic respiration. And of course, the breakdown product of aerobic respiration is water, which we can excrete, and carbon dioxide, which we can also excrete, but we need to get that to the lungs. So the level of gas exchange is occurring at the capillaries, so you can call it capillaries or a capillary bed. And here we get a pickup of carbon dioxide, deoxygenated blood returning to the heart. So returns, we have the top part of the heart are the atria, the right atrium and the left atrium, and then the bottom part, the ventricles, right ventricle and left ventricle. And the right and left is as if a patient is facing you. So if a patient is facing you, this would be the person's left side, and this would be the person's right side. And that's how anatomy that's how you identify parts of the anatomy. So deoxygenated blood comes in to the right atrium and then flows into the right ventricle. It passes through a valve. So we have these valves in the heart, and sometimes they're called bicuspid, which means two cusps, or tricuspid, which means three cusps, like this valve. So a cusp is like this. If you can imagine, I don't know, upside down basket or something. So this would be bicuspid, the way that I'm putting my hands. And if you could imagine that there's blood flowing from the top of your screen, then the blood flowing downwards would push my hands like this. But if there's blood pressure building up below my hands, then it would push my hands like this. So basically, the shape of the cuspid shape of these valves ensure one-way flow. So we have over here on the right side of the heart, we have the tricuspid valve ensuring one-way flow into the right ventricle. The right ventricle contracts, the cusps close, and pushes blood here through the pulmonary valve into pulmonary circulation. So we have deoxygenated blood coming here, carbon dioxide leaves through the capillary bed, and then through simple diffusion, which of course is based on the second law of thermodynamics. Through simple diffusion, things go from high concentration to low concentration. So there's higher concentration in the capillary bed coming from the veins, from the pulmonary artery, going into smaller arteries called arterioles, and then finally into the capillary bed in the lungs. And so carbon dioxide diffuses out, oxygen diffuses in, and then through the pulmonary vein. Now we have oxygenated blood in a vein, which is the pulmonary vein. And then this comes back to the heart into the left atrium, pushed through the mitral valve, also called the bicuspid valve, into the left ventricle. This contracts, the valve closes, pushes blood through the aortic valve into the aorta, back into circulation. And so this entire process exists because we need to get oxygen into all of our cells, and we need to get carbon dioxide out. And in order to do that, we need a capillary bed very, very, very close to all the cells in our body. And by having those capillary beds very close to those cells, we can have that gas exchange occurring. Now, we're going to look at things a little bit differently. Fetal circulation. So in fetal circulation, the key point here is that the fetus doesn't have operating lungs. The fetus is not breathing air. The fetus, you could say the fetus is breathing, but it's breathing amniotic fluid. And so it's not, because it's not getting oxygenated here, the body has systems to make sure that oxygen comes in to the right ventricle, we're going to see in a second, but shunts over to the left side to go into, the oxygen blood comes in to the right heart, exactly, shunts to the right side in order to go into circulation. So you don't want oxygenated blood going to the lungs. You want oxygenated blood going to the body system. And so we're going to see how the fetus, how that's done in fetal circulation. So that was chapter 7. We're going to look at something from reproduction and development chapter, which is in chapter 14. Okay, so here we go. So now we have something, the placenta has entered the chat. So of course, the placenta is in between mother and fetal circulation, and mother is able to provide oxygenated blood. So that's the red that's coming along here um, into the fetus. Now we can see that uh, um, and of course this is from the umbilical cord. Now we see again the red is the oxygenated blood, and here we have deoxygenated blood, blue, which is returning to the heart. Just just as an adult, we have deoxygenated blood returning to the heart onto the right side. But now we have an input of oxygenated blood from mother, and we have a new color, which I don't know what you want to call it, purplish. And this is the sloshing around of the oxygenated blood from mother with the deoxygenated blood from the fetus. And this is sloshing around in the right heart. Now, there are ways to shunt that blood over to the left heart. So there are there's a little hole in the heart, which does this. And we will see that in ACER's practice question, which is called the foramen ovale, which brings blood into the left heart directly. And there's also another shunt, which is called the ductus arteriosus. None of that do you need to memorize. You don't need to memorize foramen ovale ductus arteriosus. They're going to set up the diagram and they're going to explain the different parts. And then you have to use your reasoning as to what would be logical in terms of what's oxygenated, what's not oxygenated, and what's expected after birth. So none of these expressions need to be memorized, but it's useful to just hear the logic of it so that you can apply that logic in other situations. Okay, so that is indeed fetal circulation. So now we're going to go to the practice question. We're going to do 5 of those questions. After that, we go through the work solutions. Then we're going to go into a few perhaps more modernized questions. So these are going to be 5 practice questions. The current timing of the exam is you have 2 minutes per question to answer your questions. So you will have 10 minutes to complete these 5 questions. And you can take this as open book, unless you've already finished them, these questions already. You could take them as open books, so you can Google or, look in the book or look at your notes for circulation in order to figure it out before discussing it. Okay. And link, please. So you can get all these, questions, of course, as soon as you register for the exam, you get this booklet, the entire booklet, of course, you get for free whenever you register for the exam. So it's called GAMSAT Practice Questions. In the olden days, it used to be called the red booklet or the orange booklet, depending on the year. So 5 questions, 10 minutes. Can we get a timer, please? And of course, if you're watching this later and you've completed the questions, you can just fast forward. Okay, please go. Good luck. Okay, so let's have a look. So from the diagram, we have the pulmonary circulation of the fetus up here. Of course, pulmonary refers to the lung. If you have pneumo, or if you were to um, pronounce it pneumo, but it's pneumo, or pulmonary, it refers to the lung itself. So this is the pulmonary circulation in the lung, but we know that this is not working in the way it would be for an adult. In an adult, this is where you get oxygenation, but in the fetus, there is no oxygenation here. Instead, what's happening is the maternal artery. So artery, it's going away from mother. Maternal refers to mother. So the maternal artery is going to bring in oxygenated blood. Now we have oxygenated blood entering the fetus through the fetal vein. And so we get this mishmash. So this would be red coming along the umbilicus or umbilical cord. And this would have been the blue area that I showed you before, which is the deoxygenated blood that has come from the systemic circulation. So systemic refers to the body systems, as I said before, which could be the renal system, the musculoskeletal system, whatever type of whatever the body systems which are oxygen hungry and giving off carbon dioxide. So this high carbon dioxide blood is coming here and then mixing with the oxygenated blood, giving that purplish stuff that we saw in the diagram, entering the right heart. And then there's shunts to avoid the pulmonary circulation, shunts to go to the left side of the heart, including the foramen ovale. It's a foramen means hole, ovale means oval. And so the blood goes into the left side of the heart. And there's also another shunt or way to get to the left side, which is through a ductus. A duct is just a tube, which obviously is a blood vessel, and arteriosus. So it goes to the most famous of all arteries, which is the aorta, leaving the heart, going into systemic circulation. And so here we have that mixed purplish blood that is going off in this circulation here. Okay, and so in the first question, we want to know which of the points with the blood passing the point be more oxygenated after birth than before it. And what did you choose? A, B, C, or D for question one? A, B, C, or D for question one? Okay, so most of you seem to have it. So you know that because this is going to be oxygenated blood coming in here, but as we saw before, after birth, all the blood coming from the systemic circulation is deoxygenated, 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 and then it gets oxygenated in the lung, and then it comes back oxygenated blood. So this is going to be oxygenated blood after birth. But before birth, this does contain oxygen, but it's a combination of deoxygenated blood from the fetus and oxygenated blood from the mother, that purplish stuff. So partly oxygenated, deoxygenated blood on the left side for the fetus. But after birth, these shunts close and you get the normal adult circulation that we saw first. And in that, oxygenated blood comes from the lung, comes to the left side of the heart, and that's fully oxygenated blood. And that is N. And that's answer choice B. Does anybody have any questions about that? To see that this, in the adult form, this is fully oxygenated blood, but in the fetus, it's this mix of these two blood systems. Okay, so that's question one is indeed B, which is N. And then question two asks, At which of the following points will the blood past the point be significantly less oxygenated after birth than before it? Less oxygenated. So what do you have for question number 2? A, B, C, or D? Okay, I know some of you might be uncomfortable with that neither A nor B nor C type of responses, but ACER likes that. Not that it's every question, but it's from time to time they use that. So we've already seen that this in the fetus is this combination. So it's a mix of oxygenated and deoxygenated. But once the umbilicus is cut, then it's all deoxygenated blood in M. So after birth, M is going to be less oxygenated. And also, this deoxygenated, this mix of blood is coming up here in O, which is going into pulmonary circulation. This is presumably the pulmonary artery. And this is a mix of oxygenated and deoxygenated blood. But as an adult or after birth, it's all deoxygenated coming here all the way up to get oxygenated in the lungs. So this is deoxygenated. So when the question is asking, which of the following points will the blood passing be significantly less oxygenated after birth? Well, it will be significantly less oxygenated at M and O, but those are not options. Instead, we have K, L, and P. So the answer will be D, neither A nor B nor C. So 2 is D. And we can look at those other options, and you can see that the blood at P and K after birth will be actually more oxygenated, because after birth, it's going to be oxygenated here in the lung, and you get fully oxygenated blood right after that. So after birth, this is going to be fully oxygenated. And after birth, K is also fully oxygenated because the oxygenated blood is coming in here and then it's going out through the aorta into systemic circulation. So P and K are fully oxygenated, and that means they will be more oxygenated after birth. And L is down here, and L's not going to change. L is deoxygenated blood coming from systemic circulation. So it's not that it's going to be more oxygenated or less oxygenated after birth. It's going to be the same after birth. And that is for L. Okay, so let's move on to question number 3. So 3 is, first of all, there's a diagram, of course, and there's an equation. But the thing is, 3 is what we call a pseudo-discrete question. It looks like I hope I answered your question about L, Janet. So 3 looks like it's a question associated with the unit, of course, but it's what we can call a pseudo-discrete question, meaning that the question stands by itself. First of all, what did you choose for question number 3? A, B, C, or D? Okay, so I think you guys are very comfortable with dimensional analysis. So dimensional analysis is, a tool in mathematics, which allows you to be able to answer a question correctly, even without fully understanding the question. I know that sounds absurd, but it's true. It's just paying attention to the units, having basic algebra skills, and then you're able to answer the question without any context to the unit, because this is asking you what is equivalent to gram per liter. And so whatever information was provided prior to that is now irrelevant. You need to just do the dimensional analysis. Yes, I understand fully that some students would say that this is much more, much easier than the real exam, but the real exam occasionally has some straightforward questions. So if I'm looking for gram per liter, I'm going to generally need to have some gram in a numerator somewhere. And so I'm looking for that. I see gram in the numerator just as it is here, gram in the numerator, and let's see what else happens. Well, if I have gram in the numerator, this is in the denominator, and this is in the denominator of the denominator. So these cancel, and then I just get, I mean, it's hard to even write it. It's just gram per liter is what I end up with, gram divided by liter. And that's just dimensional analysis. I mean, ACER will have some questions like this, but usually they won't deliver it to you so straightforward in which you can just look at it. So very basic algebra skills, and that's it. Okay, and then for question number 4, uh, yeah, for the situation depicted in figure 3, point X must be. So we have figure, uh, you know, it happens like this. Sometimes you're going to be comparing two different diagrams. And let's see how I can do that easily. And then you use your reasoning skills based on these two diagrams. So here's figure 2 and figure 3. Okay, so in figure 2, it says that at point X, a quantity of dye is added at a constant rate over 1 minute. So point X, a quantity dye is added. And then we look at figure 3, and in figure 3, it says lungs add a quantity. So we have the quantity added at X, and here we have lungs added a quantity. And so what's your answer for question number 4? Yeah, so no, notice, Nora, where is the quantity added? Where is the quantity added? So the quantity of dye is added over here, and where is the quantity added here? The quantity added is in the lungs. So yes, most of you have that correct. The point X must represent the lungs because the lungs is where the quantity is being added. And of course, we know what's being discussed here. What's being discussed here is breathing and circulation. And so if a dye is being added to see what the rate of movement is, well, what is being added in our circulatory system? Well, one perspective is, especially because of the way the diagram's drawn, what's being added in our circulatory system is oxygen. And where's that being added? In the lungs. And so we have the answer to question number 4, A. And then finally, for the situation in figure 3, given these values, the question is, what is the cardiac output? And what was your answer for question number 5? Okay, had a few A's, but mostly C's, which is good. So let's write it out for question 5. What is being presented? We're given an equation. Let me just see if I can find that. So we're given an equation, Q is equal to delta C. So Q is the quantity, Q for quantity, no big surprise there. Quantity of the oxygen, and delta C is the change in concentration of the substance at point Y. Okay, so we have the change in concentration. So let's look at the quantity that's given, and the quantity is 240 mils per minute. So, of course, dimensional analysis, I just want to be careful with my units. 240 mils per minute. And then I have the change in concentration. And so it went from 180 to 120. So this is as it's going into circulation. And of course, in the back of your mind, it makes sense. Blood leaving the left side of the heart is oxygenated blood. And then when it's coming back to the right side of the heart, it's deoxygenated blood. Everything's relative, of course. So there's less oxygen that is returning to the right side. And this is asking us for the change in the concentration. So it changed from 180 to 120. So we have 60 mils per minute. And so we have 0, 0, 6 goes into 24, and that's 4 times. And that gives us the flow rate, the cardiac output. And in terms of units, I think I did that incorrectly. So that was mils per minute. And then over here, we have mils per liter. So that's mils per liter. So mils cancel, and a denominator in the denominator is the same as a numerator. So we get liters per minute. I know some people like to memorize it that way, denominator, same as the numerator, but you could do cross multiplication or whatever technique you like to do. But that's ensures that I have the correct units, which is liters per minute. And if any of you have done biomed or nursing exams recently, you might recognize that the cardiac output normally given in textbooks is actually 5 liters per minute. And ACER has 2 answers in that area, one at 4 liters and one at 6 liters. So they want to make sure that if somebody was trying to memorize any of this content, that that would not help them. So the actual answer is indeed 5C. Now, so that's from ACER. Now let's look at some let's say updated questions. And if we can get the handout for the 3 additional questions. So these are going to be 3 questions coming to you from the latest edition of the Master Series. And this will be some more updated concepts. One is straight out dimensional analysis again, but with a calculation. So mathematical calculation, still called biology, but no biology previous information is necessary, even though it would be considered part of the cardiovascular system. And then we're also going to do another type of question ACER likes, which is using percentages. It's like a puzzle, and to see whether or not you can reason your way through the puzzle. And again, very little to no assumed knowledge, but that's the way ACER likes to roll. So can we get the handout, please, with the 3 additional questions, and then you'll be given 2 minutes per question. Then we'll go through the work solutions. And for those of you who are going to be attending the general chemistry tutorial at the top of the hour, it's probably going to be about 15 minutes late. We'll start about 15 minutes late because we need time to finish these 3 questions and go through the work solutions. So if you have any problems opening the document with the 3 additional questions, please let us know. And if we can get a clock for 6 minutes for these. can get a clock for the 6 minutes. Yes. And please begin. Good luck. And yes, it's open book. Okay, so let's have a look at this. And yeah, so this is the um, ACER has, I think, 6 units in their practice questions, 6 units in the cardiovascular system where it helps to know a little bit, but they about the system in their 5 ebooks. 6 units, where some assume knowledge is helpful, but they also have units where on the cardiovascular system, similar to this, where, I mean, whether or not you read about the cardiovascular system, it doesn't have much of an impact. Um, okay, and so let's have a look. So we have we have X coming in here, and it's dividing into Y and 66. So let's just keep a little, gonna keep track of what's going on here. Okay, so we have, does everyone agree with this? Because X is making this and it's making this, but this 21 is also involved in this 66. So X is going to be equal to this plus this. So there's no previous knowledge required to make that consideration. Then you notice that 66 is making 59 plus 7. Oh, okay. So that makes sense. So in other words, uh, we're we're uh, we're using our intuition as to what is the meaning of all these different things that's happening. It's like looking at a bunch of pipes and just looking at where they divide and where they come back together. So we have now, in our general sense of this, we can imagine this is pulmonary circulation here, and we can imagine this is the right ventricle and this is the left ventricle. And so we see this is going to 59 and 7. Now this 59 comes in here, and we can see that the 59 is going into 10 and 69, or wait, sorry. This is the left ventricle. Here, the blood is leaving the heart at 34, and then 31, and then it's coming here at 10, adding to the 59, producing 69. So 69 is coming down here. And here we have 7 coming around in pulmonary circulation, and this is going to produce Z, and then Z plus Y is going to produce 34. So here the blood is coming up, here 31, and then 10. So the first question is, which of the following likely represents the CVO at W? So what is your response to question 11? Okay, so looking good. So we see that over here at 31, and by the way, you see 34 is here, and it drops into 3 and 31. So that's equal to 34. It doesn't matter. We're looking at 31 coming in. This is part of the aorta, leaving the left ventricle. This is actually called the aortic arch, not important. And then we have 31 going in. We have 10 coming down. So we have to imagine that something was lost here. What was lost? W. So W must be 21. So that 21 plus 10 produces the 31. So indeed, the answer to 11 is B. And next, we want to see what best approximates the CVO at X. And what did you choose for that? Question number 12. Okay, I think most of you have it correct. So we've already said that X is going to be equal to Y and 66 minus the 21, because 21 also contributed there. So here we have X, and we can also see that we would need to know what Y is, of course. And to know what Y is, well, here in the left ventricle, 34 is going to be X and Y, Y and Z will contribute to 34. So Y and Z contribute to 34 before it goes in this direction. So Y we can see here, and Z is 7. So we have 7 plus Y is equal to 24, and that means 34. So that means Y is 27. So this is 45, and this is going to make, well, 72. And so we have the answer for question 12 is 70%, which is A. Any questions about that? Now, you could imagine if you were to believe that you're studying for GAMSAT, and then you read a textbook on the cardiovascular system, but then during the exam, you get something like this. You can see why many students feel after they've studied biology and then they sit the real exam, they feel that what they studied was not reflected in their exam experience. And it's because ACER will come up with many tables, diagrams, graph analysis, which may be unfamiliar. And then they'll see whether or not you can use your reasoning skills to work through it, as many of you have done. Okay, and now for a final dimensional analysis to round things up. So the next question, let me just try to. So the next question is from a different chapter, chapter 7. But what did you choose for your answer, A, B, C, or D, for the last question? Okay, very good. Many of you have it. I hope that when you look at this calculation later, you will do it yourself. Okay, because when you look at a work solution, it it's not as valuable as taking a pencil or pen and doing it long form yourself. There's no calculators permitted on the exam. You need to be quick and efficient with your calculations. So, what we're looking for is beats in a lifetime. And so we're going to set up a calculation to get there. So what do we have? We have 70 beats per minute. And now we're going to bring this up because we have beats here, so that's okay, but we have to bring this up until we have this over lifetime. So how do we do that? So we're going to start by converting the minutes. So we know we have 60 minutes in an hour. I know some of you with a math background, you'll do this faster way. No problem. Use the technique you're accustomed to. Then, so I have 60 minutes in 1 hour. I have to go how many hours in a day? And then I have to go how many days in a year? And now I can go 80 years in a lifetime. And this is what dimensional analysis is. It's being very careful with the units, making sure everything cancels out, and then it's just a matter of mathematics. So here I can cancel minutes with minutes, hours with hours, days with days, years with years, and then I end up with beats in a lifetime. So that is the objective. And for the mathematics, you can you can do it many different ways, but one is that you can look at 24 because, okay, I have to underline this. There's going to be many questions on the exam where you have to make a choice as to, can I estimate and to what degree can I be comfortable with approximations? Because, if you are multiplying 365 by 24 on the real exam, then it's possible, but unlikely because first check the answer choices. And so generally in a question like this, there's going to be some sort of ACER's going to make sure that the answer choices are sufficiently far apart that you can engage in approximations. If that is not the case, and you have to be very precise, then usually the calculation would be shorter than this. So if you see a calculation like this, look the answer choices. In our case, they're 100 times different in terms of the answer choices. If it's 100 times different, if you change any of these numbers by 10%, 20%, 30%, 40%, what does that have to do with 100 times different? So that's one thing to keep in mind. Oh, so there's a question about the 70 beats per minute. Yes, so it's not that 70 beats. Okay, I'll put it a different way. So in the past, I'm not giving away something, but there used to be a question on the exam for decades. I'm not exaggerating, decades. Students would talk about this exam about the rate of growth of your nails. Yes, you heard that right. Your nails in meters per second. Now, can you imagine, like, how do you start with a number if you don't know how fast your nails are growing? And so what you're allowed to do is you just make a reasonable approximation. In fact, sometimes ACER will actually put this expression in the question based on a reasonable approximation. And why is this possible? Because if the answers are 100 times apart, does it matter if you choose 70 beats per minute or 100 beats per minute or 150 beats per minute? I hope your heart is not going at 150 beats per minute during the exam. But would it matter? It doesn't even matter because you would have to choose something absolutely absurd in order to be wondering which is the correct answer choice. So having a heart rate, yeah, whatever you're comfortable with your heart rate, is still going to work out to the same answer. Okay, so now I'm in the zone of approximation. This 24, I'm going to see is 25 because it's easier to work with. This 365, I'm going to see is 400. Again, it's easier to work with. And remember, 100 times different. It's not as if I'm increasing this by 100 times or even 10 times. I'm increasing it by a relatively small percentage compared to what the answer choices are like. And then we have 4 times 25. That's 100 plus these 2 zeros. And then we have 1, 2, 3 more zeros. 1, 2, 3 more zeros. So I have 1, 2, 3, 4, 5, 6, 7 zeros. So far I have 10 to the 7. And now I'm just left with 7 times 6, which is 42, times 8. So let's see, 1632. So let me do something like that. And then if I'm going to subtract here, I have to add there. So I have 3.2 times 10 to the 9. The answer is B. So I hope I gave you a good standard as to how you can go to analyzing, doing dimensional analysis in biology. Can you imagine? It's called biology, but it's mathematics. And hopefully you see the degree to which this occurs so that you don't spend your time, some people hours, days, weeks, months, studying very, assumed knowledge, which ACER will never really ask. So keep that in mind. Okay, so we're going to be doing this every 2 weeks. We're going to go through some more, practice questions from ACER. I'll try to announce it in a few days prior to the to our tutorials, but every 2 weeks we'll do some questions from ACER, and then I'll give you some sort of updated trends that's going on. So, and if you have any questions, you can always go to our forum. It's a free forum. You can post any questions about anything that happened today, and we will go over that again. And I'm not sure if you're asking me about questions 1 and 2. If you're asking about questions 11 and 12 for this unit, the answer to question 11 was B as in boy, and the answer to question 12 was A. Okay, so that's it for today. Good luck with your studies, and if you are going to the general chemistry tutorial, we'll start that in about 2 minutes. Bye for now, and see you next time.